Howdy, my name is Branden Limauro, and I will be the one creating and editing this video along with creating many of the graphics used in the video. My partner Phillips wrote the script for this video and helped create and design the circuit. Our assignment was to research and create a transcutaneous electric nerve stimulation circuit, also known as a TENS unit. To start this project, we first conducted research to gain a better understanding of what TENS is. TENS is a device that produces and emits electrical currents into the skin of a patient in order to provide pain relief. Now shown on screen is a common TENS unit, a handheld device to control frequency, and two pads to apply the voltage to the area of interest. TENS units are commonly used to treat pain resulting from conditions such as arthritis, neck pain, knee pain, sports injuries, and menstruation. This method of pain relief is non-invasive and easy to use. The effectiveness of TENS units are still debated, and according to the United Kingdom's National Health Service, there's not enough good quality scientific evidence to say for sure whether TENS is a reliable method of pain relief. However, many healthcare professionals and patients have reported that this method has helped in relieving pain. In terms of how it does this, according to a critical review of the latest literature published in Pain Management, TENS reduces hyperalgesia, meaning an increased sensitivity to or an extreme response to pain, through both peripheral and central mechanisms. More specifically, TENS units activate endogenous inhibitory mechanisms in the central nervous system involving opioid GABA and muscarinic receptors producing analgesia. In terms of the device itself, TENS units usually operate within a range of 50 to 100 Hertz. Therefore, we decided to create a bandpass filter circuit that would pass signals within this cutoff range. We decided on a bandpass filter because this filter allows for frequencies within a certain range to pass through, while dampening frequencies above or below this range. After deciding on a bandpass filter, we then designed a basic inverting bandpass op-amp circuit that is powered by plus and minus 15 volts. We decided on an inverting op-amp because we have worked with inverting op-amps throughout this course, as well as during our bioinstrumentation lab. In addition, inverting op-amps typically allow for lower input and output impedances. Our op-amp circuit design, now shown on screen, contains two resistors and two capacitors. For the input voltage, we decided to supply 9 volts into the circuit because this is a common voltage supply for TENS units. Because we supplied our op-amp with plus or minus 15 volts, that means we would need to have an ideal gain of 60 in order to allow for the chosen input voltage. We then arbitrarily chose the resistor 1 value to be 100 ohms, shown in the box in the bottom right-hand corner. Using the equation for gain of this circuit, shown in the bottom left-hand corner as voltage gain equals negative R2 over R1, to find that we would need our resistor 2 value to be 6,000 ohms or 6 kilo ohms, as shown in the box in the right-hand corner. Finally, we use the equations for the two cutoff frequencies of the filter, once again shown in the bottom left-hand corner as lower cutoff and upper cutoff, to determine the values of the two capacitors in our circuit. For the lower cutoff frequency, we set it as 50 Hertz, while the upper cutoff was 100 Hertz, because this is a common range for TENS units according to our research. Having the cutoff frequencies known and the resistor values, we were able to calculate each cutoff frequency algebraically to find that we needed a capacitor 1 value of 31.8 microfarads and a capacitor 2 value of 0.265 microfarads, also shown in the bottom right-hand corner. However, these values are for an ideal op-amp. Since an ideal op-amp is not applicable to our TENS unit, we would need to account for a non-ideal op-amp. There are two approaches we can make use of for this. One, change our input voltage to slightly under 9 volts, or two, change our gain value to something above 60. In the first case, we would use an input voltage of 8.9 volts or less, which is what we decided. If we decided to use the second option, our resistor 2 value would change, thus causing a change in the capacitor 2 value. In conclusion, TENS units are a possible non-pharmaceutical treatment to hyperalgesia. And while the physiological effectiveness of the TENS unit is not completely understood due to the complexity behind the mechanisms, the device itself is very simple and accessible for those in need of pain relief. Shown on screen now are our citations for all of the research that we did. Thank you very much.